Good day to you, Mr. Liebens. Are you ready to conduct business?
Good day to you too. I am indeed ready to conduct business. I require a plot of land to build my pool on.
Under what conditions will this plot of land be purchased?
My pool will be rectangular, with an area of 1,800 square feet, and two 5-foot decks on opposite sides, and two 10-foot decks on opposite sides.
I assume you would like to acquire the smallest plot of land for your pool?
Indeed, I believe we can use calculus to solve this problem.
Correct! We can use first derivatives to minimize functions, more specifically, the area for the plot of land that will fit your pool and decks.
Why can't we minimize the perimeter to find the smallest plot of land?
Since 2 of the decks are 5 foot and 2 are 10 foot, different amounts are being added to the length and the width. Thus, the area is no longer minimized.
Fair enough. We'll deliberate more tomorrow after further study into this problem.
We meet once again. After a sleepless night of study, I was able to determine the area for a rectangle is length times width. Since the length and width can be anything, so long as their total area equals 1,800 square feet, they are left as variables. But you also have to add 2 10-foot decks along the length and 2 5-foot decks along the width. This gives a total length of length plus 20 and a total width of width plus 10. I was also able to determine that the area for your plot of land is length plus 20 times width plus 10. Unfortunately, I wasn't able to determine any more.
Well then, you are in luck, my friend, because my lab results show that we could use the area of the pool along with the formula for the area to put the function in terms of one variable.
So we can use 1,800 equals length times width and then solve for length, thus getting length equals 1,800 divided by width.
Precisely. We can then determine the new formula for the area to be. Then we can use the first derivative test to determine the minimum of the area.
Well, while you were busy talking, I determined that the first derivative of the area is... This was determined through the use of power rules for derivative.
A few quick calculations show that the first derivative equals 0 at w equals 30, since it can't be negative, since the area can't be negative.
Astounding! Knowing where the first derivative is 0 gives us a critical point, which is a possible minimum or maximum for the function.
Now all that's left to do is to determine whether it's a minimum or a maximum.
Luckily, I've anticipated such a situation, and my researchers have conducted a study. The data shows that values below 30 are negative, and values above 30 are positive.
Exactly what I need. Since the slopes were negative, then reached a critical point, and then became positive, w equals 30 is a minimum.
Now, I will go back to the area of your pool and use the width value to determine the length.
So, the length of my pool is 60 feet. The width of my pool is 30 feet. But don't forget, I want 10-foot decks along the length of my pool and 5-foot decks along the width. That makes the final dimensions of my pool 80 feet by 40 feet.
Very well. I will finalize the paperwork and we can begin construction tomorrow.
Sounds good.
Well, looks like I've got to finalize some of this paperwork. Here you go, sign there. All right. Thank you. And let's get digging. Ah, a job well done.
Yes, it's perfectly designed, with 10-foot decks along the length and 5-foot decks along the width. Beautiful.
Indeed.